I'm going to go over just the answers for problems that we did in class. You can see the work in case we went too fast. The first three here are just straight derivatives. Take the derivative of e is itself times the derivative of the exponent. So you see it simplify. We usually move the variable out front and keep the e second. For these two, you have to do the product rule, and then within that product rule there's some repetition. So when you get to this step on number 4, all you have there is some simplifying after that. So I distributed the 4 and put it all over x, and this one there's nothing to distribute, and then finding a common denominator is x. So this one was already over x, so to make this one over x you got to multiply that by x, and so then this whole thing is our numerator, comes together. When you have an e in a product rule, you're always going to be able to factor out that e because it's going to be in both things. So I factored it out. You could also, if you were solving this, you could factor out a 4x out of everything, and so you'd have 4x e to the 4x to the 5th, and then you'd have 2 plus 20x to the 5th plus 5x to the 3rd. I mean, you could write it like that too. It just depends on what you're trying to do with it. Down below, integrals, general rule, let the exponent, when you have a polynomial exponent, let that be your u value, and substitute. You want to get it down so you have an e to the u. So this 12 and 24 cancel out. The 2 is just going to be along for the ride. du over 3, this 3 and 45 cancel out. E is along for the ride. 5x squared plus 1. The 10x's cancel out. So you always want to get the form of e to the u. You may not be able to follow this one very much, but the derivative of sine of negative 2x is cosine of negative 2x times negative 2. So when you bring this over, there's a negative 2 left over. That's why this negative 1/2 is out front. And then you substitute back in. Your final answer is right there. Same thing here. Cotangent derivative of that is negative cosecant squared times negative 1. So it becomes positive cosecant squared. So this is what I'm substituting for dx. And it leaves me with a negative 3, 1 over u. This is a natural log one because it's u prime over u. I strongly recommend you look back through your giant e to the x packet. There are a couple of integral problems like this. There's a strategy you need to do. This is not u prime over u. The exponents aren't the same. But you can divide every term by e to the x and rewrite the problem. And then it becomes easy integral. Integral of e to the x is e to the x. Integral of e to the negative 2x is e to the negative 2x. But I want that to be a negative 1 because the derivative of e to the negative 2x is e to the negative 2x times negative 2. Well, that's a positive 2, and I want it to be a negative 2. And then the integral of e to the negative x. So you can always check your answer by taking the derivative. E to the x, e to the negative 2x times negative 2, that makes positive. E to the negative x times negative 1 makes positive. If you see one like this where there's e's, go ahead and set the denominator equal to your u and see if it's the same as the numerator. So when you solve this for dx, those will cancel out. You're going to end up with a natural log function. Take a look at your problems from the book on exponentials. Those are good things to look at in solving half-lives and double-lives. Quick review, if it's a half-life, that means that whatever you start with is you're going to have half of that to end. And so the c's cancel out. So you're always going to be solving using natural log of a half equals kt. And they're going to tell you k or t, and you're going to find the other way around. If it's a time to double, like something that's increasing, then your c value is going to be doubled, and so you're going to be ending up taking the natural log of 2. If you're looking for shortcuts, when you solve it in finding k. You can always, if they give you half-life or double life, it always cancels out one of the variables and gives you a time, so it gets you down to one variable.